olisi aika hyvä kenno, niin voi sitä kokeilla, että jos laittaa valoja vähän poiskin. Kyllä se pitäisi pystyä kuvaamaan.
Good morning, everybody, and it's kind of our final day, and I hope you have had a nice week with us. And now it's kind of idea is to summarize the week and what kind of results we have got from the laboratory work. And I think first we look at the agenda today. So summary the week, and then we have a results from every team, and then we discuss about challenges and what kind of if you have some kind of ideas how to develop further, or if you have some problems doing the laboratory work or all kind of things. Then we discuss about the next workshop in Zvolen, and last Tuesday we had a meeting with the teachers, and we decided to organize the next workshop in Zvolen, but 11th of and 11th, 15th of May, so that's week 20 in Finland. So for at least I live here in Lahti University of Applied Sciences, these students, we are continuing with the same students. So in the autumn time, the younger ones are coming to involve. Okay, first of all, I would like to know about team leaders. Could you tell us that what kind of feeling you have after this workshop week, or the teamwork, anything? So could you tell me something about how your teamwork has worked? Something?
Well, I think it works really well.
Okay.
Some work a little more, some less, but I think everybody kind of tries to be involved.
Okay, that's good. That's good to hear.
I think everybody paid attention.
Okay.
We were kind of like a team.
So you organize the teamwork that everybody has kind of some tasks during the weekend.
And also it's just quite nice to get to know each other.
Okay.
Which is also a point maybe.
Yeah.
Generally I think it's successful.
Okay. How about you, Jane?
Exactly what Martin said.
Okay. So you don't have any extras?
We had a really good team spirit also. It was really nice week.
So every two students have kind of different tasks during
Yes.
the week, and same thing with
And
the
the
report.
lab and everyone doing the report. And
Okay. Joni?
The other teams and we had no problems actually. Also.
Okay. So then I heard that you had some kind of party in Wednesday. So could you tell us, teachers, something about it? What kind of So you don't want to tell it? Talk about it, okay. Oh, I'm very pleased to hear that you had a nice time anyway together, and I had also discussion with the Jotka, and thought that it's really good that you found each other and you start working like in a workshop group and continue that work. But maybe it's better go to the results, or do you have
Maybe it would be good if the whole group would be
Yeah,
there,
yeah,
so
if you
we
would,
can see that who were in Martin's group
in your
and
group.
I have it written here, and I have the presentation.
so just call Martin's group.
Okay, key group number 1, please come here and Martin will introduce everybody.
Vesa. Is it quiet or what?
But I should be the speaker, or someone else should kind of look?
Maybe it's better if you introduce first your group and if they have different roles in your team.
So I hope that they prepare themselves, like the speech or the presentation, because they made it.
Okay.
So I think they will the best for them to step forward and.
So can you switch off the light because the projector is not very strong, so could you please try it, yes? It's better now.
Don't.
So yeah, can you
Yeah.
then see?
So maybe I can just make the introduction to the presentation.
Yeah, please.
So I am the group number 1. So this is my group. If there is any importance of saying names, should I also introduce?
Yeah, if you can, yes.
So food especially. I'm not sure if I know who is who. Yeah, but I know Marco, Oscar. So you know that it's March, and Peter, Jakub, Ali. Yes, this is my group. And we had what was the difference between the groups? We had pine as a species to test, and also another difference that we had in comparison with other groups was applying treatment, the surface treatment, which was water glass, and I think all the other parameters were similar with other groups. So now I can just give the word to someone. I don't know who is like kind of brave enough to present. Maybe you can. Oh yeah, me too. You too. Right, so please control those.
So this is the aim of the work. We used the pine as a wood species, and we applied the surface treatment by water glass. Then was also look at the samples with the moisture content of 6 to 8%. These are our conditions. The wood species is fine with those dimensions, as you can see. Our first moisture was 44.4%. And in the 3D hot forming we use temperature 160 degrees of Celsius. The 3D hot forming process includes 3 steps. The first step is we use time 15 to 30 minutes and pressure by 15 bars. The next step was about 105 minutes. We increase the pressure on 30 bars, and after this step we apply the water glass. It's because we want to improve the properties of surface. And the first step was only about 15 minutes and the pressure was the same as in the second step. This is our final samples after all. As you can see, we didn't achieve the goal as we wished because the surface wasn't very smooth and also the structure wasn't very uniform. And as you can see, there is a pretty rough surface on the top of those samples. And we also cut this sample, and you can see there are so many fractures or cracks. And this is the result of very high temperature drying, and the water goes off of this sample too quickly, and this is the cause why there are those cracks. Okay, these are our results. Our moisture content was only about 1.29%. It's much lower than the moisture content what we want. Also, the structure has some defects, and the profiling was also not very successful because the grooves weren't uniform at all along the sample, and we also didn't achieve a smooth surface. These are some of development ideas, and Peter, please reply to me. Or Balázs.
That's indeed. Yeah, it's some development for sorry, I don't. But tell me, you are helping out.
So I think during the drying, during the pressing process, we couldn't have the exact moisture in the whole volume of the wood. So I think it wasn't the best way to dry the wood. Yeah, I think the samples weren't parallel-sided, so our press was a little bit ununiform because there were smaller and higher thicknesses. Yeah, I think we could try it with lower temperature because we don't let the steam, we don't leave enough time for the steam to go out to leave the wood.
Do you have any proposal about the temperature? What would be
Well, I
ideal
think you
temperature?
have to do many more experiments, like, I don't know, maybe 10 or 100 of experiments to know what's the exact temperature you need to use for every piece. Then, yeah, we didn't really have the right side of moss, because I think these tools we used were too deep, so the wood couldn't fit in the whole group. Yeah. And if it would have been a little bit smaller, then the wood could just fit in the whole group. It just, I don't know, like, went as it wanted, so we didn't have a control over it. Yeah, and the funniest part, I think, was that we didn't really count the amount of the treatment we put on the surface. We just put it like, I don't know, we didn't calculate it all. We don't
Too
know how
much or
yeah,
too less.
or- yeah, too much and some spaces or some surfaces and too less on the other one. Well, I think one more idea is to drill some holes or use a profile side template so the steam can go out there too. Yeah, many of these things. Yeah, so good.
Okay, so thank you for attention.
Okay.
Martin, do you have some comments about your work before we start the discussion?
Well, pretty much we kind of like sum up to all problems that we have had during this tree harvesting. I think I kind of said what suggestion would be, and I think that might be still something to come up with and something more. Well, pretty much probably that would be all. To say.
Okay, if we start with the tier one, maybe start the discussion.
So,
Could you put the tier number one, start it again, sheet one, number one.
oh, that's not okay.
Okay, maybe it's the next one, where's the measurements before, first.
Next one.
Okay. Please press the F5. Okay. So, well, we can see that, at least we can see that the thickness of the sample between the sample 1 and 2, there's a difference, it's not huge.
One reason must be that the other sample has been in the bottom of the water and
Yeah,
this
maybe.
one is having half in the air, because otherwise we put those underwater on last week and it was Friday morning, so they have been under the water so more than 4 days. Maybe that was not enough, because the moisture is only 44%.
No, I was also surprised that I was expecting higher moisture content.
Yeah. But it's interesting to hear what the other people, what was the starting moisture and the final. I didn't hear quite what was the final moisture content you ended up
It was
with.
like 1 point.
So it was totally dry.
29% of moisture content.
That's surprising for me.
I think one reason for the low moisture content is also because of the pits inside the pine tree, the border pits, and that makes it harder to saturate another species. So that could be
Yeah.
the other reason. It maybe needs a lot more time to soak than the other.
Yeah, we should use the fresh timber, but unfortunately we had all this human timber and then struggle again. So, I'm quite surprised about the thickness difference. Yeah.
What was the
Bratislava, please.
what was the initial moisture content of individual species? Because I think this 44.4 is average, I guess.
Okay.
Martin.
please.
Do you have a further information?
What was the?
Initial moisture was 44.4,
Yeah.
and I think it's average from both pieces.
If it's average.
Yeah. So what was the moisture of one piece, and what was the moisture of the second piece? If-
Do we have this information?
I think we only measured only one. You know, the one we got in 3 pieces.
Yeah, we took only one piece.
Okay,
of,
okay, I got it. Okay, so this is the measurements from one piece. Okay. And
Because
it's
we were
average.
expecting that is that because these are cut from the same
Okay.
same wood, so that,
Yes, yes, yes.
there is only need for
Yeah.
like one.
So
one.
this is average from two sides and one middle.
Yeah.
And can you explain or can you show us or tell us what was the moisture differences between ends and middle and the
Yeah,
others?
well, we will have to put the reports there. There is a table.
At least roughly, it doesn't need to be.
Yeah, we can read it later if you have a rush.
My point is
is like
half percent.
half a percent. Yeah.
There wasn't a big difference.
Okay, that's enough. It's my question is answered.
Which can I put it on? It's like weekly.
Half a percent is nothing.
So it was here. Oh, it's from this. Yeah,
Yeah.
so the average was 9.29, and then the highest was 1.49. So it's really like just a little difference.
Okay.
Other questions? Other teachers?
Maybe the treatment also, the main reason why the treatment didn't work was probably too much thick layer spread on the top samples. And maybe another problem that could have been there is that the surface wasn't totally even. And there might be also the problem that those plates which were placed on top, they didn't touch the whole surface in the whole length. So there might be kind of like a space between the surface of the wood and the surface of the plank. Because we had also the problem, maybe all other groups, they had the same, that the shrinkage was too kind of like extreme. We had those stoppers of the mold, and the shrinkage like came under, or the dimensions of the samples came under those stoppers in the mold. So that made a little bit uneven pressure also during the pressing time and caused this kind of imperfection in the surface in smoothness and so on.
Do you have the samples here so that we can have a look about the surface?
Is that yours? So there was no name. Oh,
I think you took the one that we made before.
yeah, I think this is the old one. So I tried to
Okay.
find you the sample, but
Well, I have one.
have you one? Okay, the actual one. What do you think, Ratislav? So should we go on with the water glass treatment anyway? So when thinking about the next step in Zvolen.
I think okay.
This is also one.
It depends. Would you like to treat, or would you like to test one best choice we will find out today, or we will test all three of those? So I think water glass is a good idea because I think you need to have some treatment on top of the wood, especially when it's thermally treated, like as this one. Otherwise, you will have some color changes later on in service conditions. So there has to be some treatment, sure.
Yeah.
Or let's say if we will doing this one technological run, pressing and heating and drying and everything all together, we can leave it for customer to choose whatever they wanted to put on top of this material. So both choices are available or feasible. My question is, could this be could this we make kind of better? Shall we play a little bit more with technology and find out what's the best choice to create nice surface with the water glass? Shall we go to this direction, or just keep it as it is and test it?
We have to decide
Yeah.
today, so,
Yeah, we'll see how these other
yeah.
Yeah, we
materials
need to
will end
collect
up.
the feedback and
Yeah.
when we are making the test pieces to the next workshops.
So maybe we may also can improve it a bit more, because we had also the problem that we were like, when we were tightening, fastening the screws, there wasn't anything on the top, and it was like lifting up the samples. So that was a little bit like kind of problem with tightening or fastening of the screws.
And we also didn't know the distance between the side templates, you know. It was just random.
Yeah, we will just kind of like make it tight. We didn't kind of like, we didn't know what dimensions we want to have like in the end. But, it's also a little problem with the shrinkage all the time, that if you want to make a mold, we always have to consider that what will be the final shrinkage or final dimension of the plants, because if they shrink too much, then the mold actually is not effective then anymore.
Can you still show the final dimensions you ended up in your presentation? It doesn't matter which one, but report over. Because it was mentioned here that 32 by 125 by 400 was the target.
No, that is only the weight difference.
Is that in the beginning or after hot forming? Beginning. What was after hot pressing? The dimension?
No, you have this information. So put the dimensions we showed before, just so we can see the difference.
The average was like thickness was 27 millimeters, and the other where you just shrink like 4 millimeters. So it's like 127, 23, sorry, 22 and 23.
Yeah, so from
123.
Yes.
so from 126 it got to 123, and from 32.7 it got to 27.
Which one? This 27.
Okay.
Yes.
Okay, so we had like the highest shrinkage in the thickness,
Yeah.
over 5.
Can you please add those numbers
Yes.
in the report so that
Okay, we can do that.
it help us to make the next samples for for next workshop.
We can do it like later, like on the
Yeah.
computer.
I have a question for the
Yeah.
whole group.
Yeah.
Basically, you start from 44% and you end up with 29, as I understood. Moisture content,
We ended up with 1.29.
percent of moisture
Yeah.
content.
Yes.
Wow, so we all dry basically.
Yeah.
Uh-huh. Okay.
It was too dry.
Yeah. So what would be your suggestion? Wanna just decrease temperature or you wanna
Either temperature or either time.
time?
These two kind of factors affect this final moisture content. So we will have to play with these two parameters to.
I think also the initial moisture content is an important factor. I don't think that these were such, solved properly because of the order of the peak aspiration. It takes a long time to pick up moisture.
There's also
So all process basically is initial moisture content dependent.
So it's quite hard to set up those two parameters because in real conditions we would probably have always different moisture content. So there would have to be maybe some golden kind of like middle or
Maybe grading or something.
something that would fit for most of the moisture contents. Or maybe it would be good to adjust during the pressing time, or during the pressing to adjust those parameters according to moisture content, which would have to be measured like during the procedure. So according to that, we could like kind of adjust the parameters. So that would be the solution.
Any other comments or questions?
Samples are somewhere, so. We could look at again the samples.
Where are the samples?
Yeah, here. Two. So
Maybe I have one
Yeah.
question for all group. If you will, this will be probably decking, final product for decking.
yeah.
What would you like to do for future with this product? To have it light material as it is, or to compress it, let's say, to half of the thickness and make it more dense and use it as such material for decking? What would be your opinion? Because it kind of affects the technology. You want to just crush it and press it and keep it stable by temperature, or you just want to dry it at high temperature and keep the same dimension as it has for natural wood, untreated wood.
Well, probably we always have to compress it a little bit because if we want to also do the profiling, we must apply some pressure. So there probably always will be some compression, but maybe if it's like meant to be like flooring or like this terrace flooring, for example, it's good if it's also powder because this prevents from abrasion, and as we also maybe compress it, and it's more stable to the moisture. Kind of when the moisture affects the wood, it's more stable because we kind of like eliminate those spaces for water to come inside the wood structure. But definitely this hardness would be nice to have. So I think I would compress it. I don't know what other
What was the
opinions.
density after pressing, before and after pressing, so do you have that?
Yeah, sure. like 562.77 at the beginning with the whole water.
And after pressing,
And after pressing, it was 472.
How much? 472?
You said 472.
472 was after the drying, and 500 also started.
62.
60.
Yeah, this is probably because of moisture.
So kind of almost 100.
You could do some pre-measurements to show the difference.
There was also one maybe detail with when we were measuring the final density, because we, as you noticed, we had these profiles, and that makes it a little bit more difficult to count like really exact. There might be something that little bit maybe affects this density at the end.
So you take the measurements above that slide or next to it? How do you measure thickness?
Well, yeah, that's. I think that they try to measure it like the side,
Okay.
and then maybe one more measurement was made in the grooves. So we kind of like decreased
Yeah.
the mass of that. So that's what the problem after to really determine the exact density. Because
time
we
I-
have some profiles there, and
Next time I would rather go for real thickness without those bumps. And
probably.
both because those bumps are very low volume compared to other whole mass of the board.
Well, it depends on profiling, but there is a mass like which is like removed.
Yeah.
So maybe it's only like 20 units in overall. But maybe it's not so significant to maybe like point out.
Anyway, those 472, it's quite typical density probably for pine.
Yeah.
So it's not very dense. It's basically
Yeah.
typical pine.
Yeah.
Could be a good idea to calculate specific gravity other than density,
Yeah,
because
yeah.
that's, then you can compare.
Yeah,
It doesn't matter if it's wet or dry.
yeah, perhaps that would be good.
okay, any other questions? So shall we change the group of what we have a kind of
Conclusions, kind of developments, ideas to how to develop
How they
for next workshop.
you mean like
The process.
concerning
Yeah,
process?
controlling.
Mm, Well, maybe we would have to like maybe more control these samples, like try to make them more uniform in the moisture content, to know that both are maybe some kind of some control room with the temperature and moisture content, so we can kind of make sure that the samples are the same. That maybe would be good. And during the pressing, maybe. Yeah, maybe it would be nice to somehow try to measure the temperature with these devices, like one of them. So we can kind of like already be aware what is happening, how much water is like being kind of evaporated during the process. I don't know if anybody else has some other idea, please just speak loud.
Yeah, just a little plus. It's my opinion only because maybe it's wrong, but I think that water glass as a coating is not gonna work because it's too much of a fragile, mineralistic like surface, and if you just push full pressure on it, it will just break. As I watched your sample, I saw it that it was kind of like a crushed stone pressed into the top of the wood. So there's no way that it's gonna be a smooth surface like this.
Well, I'm not sure, but I think that has been done before, this kind of treatment, and I think it quite worked
Yeah.
before, because it wasn't, we haven't done this for the first time, I think. I think that was kind of suggested already on some experience
And
before.
did you press it before the water glass dried, or did you wait for it to dry? Before, not now, before.
Well,
Well,
I haven't done this, I haven't been part of that experience,
I
so
see.
I'm not totally sure how that was like kind of going on. But I think because that if you can notice, maybe some parts or some areas are kind of like successful. They are quite very smooth.
Yeah.
I think it was just like, I think the problem is with the amount of the spread, and also that you have to make sure that the press will be really pressing that area.
Yeah,
Because if there is space.
the question is whether the good parts on it, that is pretty smooth, is the parts where the press managed to
Yeah, I
touch
think
it,
it's that.
or whether the other parts, where there was no press. I don't know which one.
Yeah, like there was the
solution.
press, there was the smooth surface was kind of created. But there wasn't pressure, there was just also air and kind of this substance on the top, on the surface, was not reacting in the right way.
I
There
see.
was like too
Yeah,
much
yeah,
too
yeah,
much
maybe
heat.
that's it, yeah.
But a very good question, and we have to study this once more before we continue making the samples for Zvolen. The idea is, of course, not to wait 2 hours that the water
Yeah.
glass penetrates, because the hot press will wait all the time. So the idea is that you have to be as fast
Yeah,
as
of course,
possible. So
Yeah, yeah.
in this process.
Yeah, yeah.
So that's the problem. But very good comments. Thank you.
Maybe I can show you, I have those one work which has been done here, and there is this treatment with paraffin oil. So maybe I can show you like what it should look like when it's like successful. This is the treatment with paraffin. So you can see like what it should look like. It was smooth and it penetrated inside of the structure. So it also will serve to prevent some conditions, like weather conditions, kind of protect it. So I think it's possible to treat the wood using 3D hot forming, but we just need to find the correct parameters for it. For example, in this case, it was 30-40 bars, 20 minutes, and maybe here, I think with these samples, I'm not sure where those. What was the starting moisture? I think it was somewhere
You
here.
can show also the latex treatment.
Yeah. But for example, here you can see that this previous timber was of 50, 70% moisture content when it was treated, which is high. Like that was the final moisture content somewhere. Oh, maybe here, yeah. Oh, actually, here's a good figure with the representation of moisture content. So, like fresh wood, when it was treated by a treated hot point, it was 20 to 25, and then you ended up with 4 to 6%. And also, it has been done this treatment of latex and paraffin. So and it was successful. Of course, I'm not sure different like how it works with the water glass and how it works with the paraffin. Maybe this paraffin is more suitable substance to treat. If it also has the same kind of properties of smoothness, then maybe we can replace, for example, water glass with paraffin.
Yeah.
Maybe it works better.
Yeah, that's a good idea. Good comment. Okay, thank you. Okay, team number one. Okay, then we go to the team number 2. Yeah, this team number 2. So if you could introduce your group. Also, we have the samples to maybe so the samples also. Okay, and you had a large.
Yes.
And you see what's
I'll put some samples going around from here.
that I'm kind of taking.
So that we are group number 2. And in this group we have Ben, Vesa, Andre, Jana, Jonas and Jan. And the difference was that we were making terrace flooring, so we had a profile on both sides of the wood, and we didn't have any surface difference. And I will now let Vesa and Benny do the introduction for you.
Yeah, so as Jenny said, we had, I don't know if you already said it, but we had larch as a species of wood. And first up was the soaking, which kind of maybe didn't work so well for us, because I think when the first group took the pieces out of the water like surface lowered, and we could see like the plants were half in the air. So it's not a big problem, but the results can't be consistent if it's done like that. Yeah, just go ahead. And yeah, and so when we started making the terrace flooring and took like the moisture piece, 100 millimeters out of the one end, we could see that it wasn't like, it hadn't been soaked all the way through. The water hadn't like penetrated. It was only like a couple of millimeters from the surfaces. It was wet, but in the center it was pretty dry, or actually really dry. So it was like, when we put it on the scale, it felt like it was soaking wet, but still we only had a beginning moisture of like 27% or so, and it felt like it should have been a lot higher. Not much to say about this, we've all been weighing out pieces. So anyway, what we did, we had, like Jenny said, we had this profile on both sides, pressing, and also the sideways pressing, which I think we should maybe work on that in future. If we're making more of these like pieces, we should rethink the mold, because there was this, when we were pressing it sideways, it was like swelling the wood, and it came on top of the mold, and then it was like squished between the mold and the heat elements, and so that's not really good, and it's kind of hard also to measure the final dimensions after that. Yeah, just go to the interesting part with the screw-ups. Yeah, skip this. So we had the steps. This was our program. So first we went for 5 minutes in 10 bars, and then for 5 minutes at 15 or 20 bars. Again, something we should think about, I believe, because
we were like jumping 5 bars or more even with each, like we were watching on the road, and when like 5 minutes has passed, we just jump up 5 bars. So from like a quality point of view, that's not a good idea. Maybe we should like increase the pressure little by little. Maybe build like some kind of extra machine for that or something. Hard to do by hand. And then after that, after those first 3 steps, so the 2 5 minutes and one 15 minute and 20 bar, we took it out and we tightened the screws around the side pressure. We adjusted that, and I think also we kind of noticed the same thing that Martin was talking about. Kind of it was lifting in the middle. Yeah, and that also contributed to the problem with the swelling that I mentioned that comes on top of the elements. And then the final step was 2 hours at 30 bars, again with a jump of like 10 bars at once, which is kind of a huge gap, I think. We could see, we were talking with Ilkka about this, and we could actually see like the cells of the wood and the grain breaking. I don't know where the samples are going now, but if you look at the like right next to the friction pattern, like on the surface, you can see like cracking, and well, there's cracking all over it, but in the middle you can see the grain has been bending, but it's not like smooth bending, it's been cracking. So from like if you are making terrace flooring and you want to make it of course like durable and strong, then you can't have those kind of like strength defects. Yeah, and after that, after we had, and after we like took it out, after this whole 2.5 hours had passed, when we lowered the mold, instantly, as soon as it dropped like 1 or 2 millimeters, we could hear cracking noises like loud bangs, and it was, at that point, it was pretty clear that it hadn't gone to plan. So, well, you can see something about the cracks on the pictures. If you can, I'm kind of feel bad for not having the worst cracked part here. We had this plank that you could also almost like see through if you look at it from the end. I don't know.
What was the reason for that fish?
Well, you can say something.
Yeah, I think the reason was like, because there was like 2 samples of it, and this one was with a stronger side down. That was the reason, because the other sample was like with a stronger side up, and it was much more better. So I think
we will go into this in the suggestions deeper, because that was I think a very important realization for us. It was a mistake, but it was important.
Maybe it was a good mistake.
Yeah. So, yeah, do we give some additional information like numbers, or keep them in the shadows?
If you're like interested, so what was with the shrinkage of the, while the pressing was going on, we started from the only real shrinkage was with the thickness, so we went from like 36 millimeters to 29 millimeters. Don't know if that counts for a lot or a little, but anyway. And with the moisture, we started off with 27%, and we ended up with like 4.5. But again, the 27 is not consistent. It's not the same throughout the whole piece of wood because of the soaking problems.
Yeah. Well, we really thought this through as a group. I think I can say that, and came up with a number of suggestions. Not really solutions, I can say that, but interesting ideas to think about. So let's jump right into it. The first thing is pretty much straightforward, but we really need to think about that, because if we compare other similar technologies and forms of 3D hot forming or just similar technologies, let's say that, we need to measure how much more expensive are those, and did we get enough success with this method. Because, for example, if we make this 3D forming, then the wood structure will change pretty much, very much. So, for example, after we want to work with tools, with these wood boards, then the tools will have a harder time, for example, cutting or just forming the wood than before the hot forming. So we need to include these if we are thinking about the finished product. But that's pretty straightforward, yeah. The second thing is that everybody, and I think every team is faced the problem that the moisture content is pretty much uneven. The soaking was not in a controlled way. We thought that maybe if we use, for example, a steam chamber or at least more water to top off the wood and let it soak for longer, then it can really improve our achievements. As mentioned before by Reza, we saw that not every part of the wood is at the same level of moisture level, and this is a really
I have to tell that when you started to work on Tuesday, all the samples were underwater, and when the first group took their samples, so it happened that maybe some samples were a little bit under the air or under the water, so it was only 3-4 hours, or not
of
more
course,
than that.
I'm not saying that this is the problem and the solution for every mistake or error we witnessed. I'm just saying that this is more important, I mean the soaking, than we thought before. So we need to work on that more. Work with different soaking times and maybe even different soaking temperatures. We'll go into the large density because with the softer woods the other teams used, it's much easier to soak them, and with large we definitely need more time. Okay. This was suggested by Andre. Do you want to say it or just let me? As we know, till about 30% of humidity, there is no real change of mechanical structure in the wood. But after that 30%, of course it's differentiated in every species, but about that content, the walls of the cells begin to fill up with water. It's free water. And when we press this filled up water, then we think at least cell collapse occurs. So the most important thing is the main problem. It's not the amount of water inside, but the speed of effluxing, so how fast this water wants to get out of the wood structure, and the evaporation of the water. So if we make it slower and more gentle, then maybe we won't see that much cracking or that much problem later.
So essentially what you're saying is that because water as a liquid is incompressible, then that could be causing because of the pressure application if you apply it fast and it doesn't have time to evaporate.
Yeah, that's
an interesting suggestion.
What was the starting moisture content when you measured the large samples? So
it was
in your case?
You mean like before we started doing it? It was around 27.
27. Okay.
Yeah.
So we didn't even reach that point.
Yeah.
Maybe on the outside walls of the wood, but definitely not in the middle.
So the idea was that we will get directly from the sawmill these samples, but we couldn't do that. So that was our problem. So in the real life, if someday some company will find out this technology, so of course it works like so that it's directly coming from the sawmill, and then after that 3D hot forming, and then it's a ready product. But now we were forced to put those 3 different wood species underwater in order to have, our aim was that you have the same starting point, but now we can see that it was not the same starting point. So, and maybe that was also good. So,
yeah, yeah, this is interesting. Maybe false, also, but it's a thing that was suggested. So if we think about it, let's just say that we managed to get the wood soaking wet. So the water is in every part of the wood. Then the fibers are full of water. And when we press this, then, as we know, the 2 ends of the wood will be the most likely part where the water tries to escape. And if we pressing it, the water in the middle of the wood have to move much longer way than the one in the 2 ends. As maybe you can see on the finished product, it's kind of puffed up in the middle. It's like this.
Like popcorn.
Yeah, like popcorn. Yeah, that's it. Because in the middle it's much thicker than on the 2 ends. That could also be because of the pressing itself, but we thought that if we want some solution for this water problem, then maybe if the end product let us do that, we can put little holes on the bottom of the board, and then if we press it, there will be much more open areas where the water can.
Basically, it's a shortcut for water.
Yeah.
There's a way for water, and it's too long, so it's destroying the cells from the inside. And the main idea was like shortcut.
Yeah, and
very
also,
good content, very good development idea. So I like that.
there's also about coming back to the uneven moisture in the piece of wood. So when we were pressing, I think maybe part of the puffing in that board is because of like the water it tries to escape or at least transform to a drier cell in the wood. So if it can't escape any other way than out of the like edges. So the center of the wood, which is totally dry because it hasn't been soaked enough, is like sucking the moisture, and it like takes so much longer time than on the edges just to boil and get out. So it doesn't even, in these 2.5 hours, it doesn't even like get a chance to get out the water.
So what was the end moisture content? So in the middle. So did you test that? So
I only had like this 4.5 was the end moisture, but that was, I'm not sure which part it was from.
because you got that in the 3 pieces and you measured.
Yeah.
Do you have that information?
Not right now, not yet. But I'll have to send it to you. No.
Please add that
Yeah.
into your report.
Yeah, also the press itself and the mold itself leaves little place for the water to leave. So if we just use little gaps or canals in the mold itself for the water to leave, then it should improve our end product.
I've been wondering because isn't there like 3D presses that actually press on like all sides, like 2 sides vertically and 1 side in top. So I'm wondering if anyone knows about these machines, like how does the water escape from that? Like now we only have the ends free for the water to escape, but in some industrial machines that I've seen, there's pressure from all sides.
Yeah.
So there has to be some kind of way for the water to expand.
Yeah.
So maybe we should look into that also.
Yeah. Yeah, we have to think about also the future and during this project. So I think that we will even make a proposal for this kind of machinery, so that how it should work and how should it look like. So that's the idea. So that we're going further all the time. So.
Yeah, that was my idea. I don't know whether the others are agreeing with me, but maybe we didn't leave enough time for the wood in the press to change its structure. So I was thinking about, of course, we wanted this method to be fast, and as you said, the wood just leave the sawmill and then just press it at that moment, and it's fast and easy. But I was thinking that if we just pre-cook the starting material at around 120 degrees, if I'm correct, then the lignin starts with plastification. The lignin plastification starts, and then we put the wood inside the press.
Yeah.
And then it will be in a much more workable way than if we just, from the start, we just put it inside and just let's go and. Yeah, as we mentioned before, the large we think is not an optimal wood, or at least we need more soaking for it, because the density is higher, and it's not just moisture levels, but the tension builds up much easier in the larch than in spruce, for example, and that is a problem. So we need to think whether we can use high density wood for this method over.
I have a comment to that.
Yeah.
Probably it won't be density, but it will be large. And the main reason I see is porosity, the way how water goes through the wood.
Yeah,
somehow.
that's good.
You can have even more dense wood, but the porosity is very high, which means the water has way to go away, and you end up with no such problem like a large.
Yeah.
I was a little bit surprised. I'm curious how the third group will end up, because spruce is also kind of not very well porosity material, but it really depends on the way of drying. But anyway, I just see that larch is not very permeable material, which means there is no way to water go out, and we have to find out other way. And it relates that this point is relates to number 4 you mentioned. We need to find a way how to get water out from the wood.
Without damaging.
Different. Besides that longitudinal direction, we have to deal with other directions. Yeah. And the only thing I'm thinking is that we need to have a press which heats up the wood from any side, basically any pressed side, but at the same time it needs to allow somehow water goes through these plates, compressive plates.
Yeah.
Have it some porous metal sheets on top and the bottom of the wood, which allows the water goes through those metal sheets away from the wood, or have different layers. We need to find a way how to get water out perpendicular to the drain. Yeah.
One thing came to my mind about soil. So we can see that this is kind of sideboard from this point. But the other pieces, there's a kind of hard involved. And there's also track problem then. As you can see, there's a hard veneer here, and also the other sample. I think it's here. And this is totally sideboard.
Okay.
So there is kind of no tracking problem. What do you think?
I think when we will cut this, there will be crack inside, the same way as here.
Okay.
Because it's
So maybe we
Go this
have
shape.
to do it and check.
Yeah.
There is,
It's easy.
Do it on the next week and maybe tell you.
Just cut it. Yeah. Okay. No problem.
Good comment.
I think crack will be surely inside
Okay.
because of this not good way of getting.
This is how you discuss.
This is kind of sidewall, yeah, and there's a hard wall on the side. So you can see the cracks, but here you can't see the cracks, but Rasmus said that it could be open this there's a new side.
Yes,
So maybe.
yes,
one-
I'm really interested because that is the success of our experiment, and we didn't cut it.
Yeah, so maybe on the next week we can cut and look.
Yeah.
Yeah.
Let's see what is inside there, because it's not normal to see that.
Yes.
Much deeper in the middle, so I've never seen something like that, but there must be something inside.
Yeah. You can see Jenny is coming back with some of the worst samples. Just agreed that you should see like how bad it can get. So it's not going to be like that. But
Okay.
Yeah, that was mentioned also before, and Vesa already said this, that the pressure build-up was maybe too harsh for the wood. Maybe we could use some smoother build-up or longer build-up. But what I was thinking is that we also had build-up for the temperature, because we just pressed it with 160 Celsius degree, and for example the water on the surface just evaporates at that moment when it touches the press, and the inside it's still cold. So if we just go from a lower level and build up the pressure, the temperature, then maybe the water in every part of the wood can adjust to that temperature, and then there will be not these high tension problem build up.
and also, if you think about it from like a visual point of view, like you said, like as soon as the heat elements touch this wood, you can see it's been burning right here because there's no time for the temperature to like settle and get to where it's supposed to be. If you look at this side, which has the like the metal plate, the mold, and it heats up like gradually. There's no burning here whatsoever. And here we have like these almost black grooves. So if you want it to look nice, that's also helping with that. Hey, there's some bad pieces. You want to see them?
Yeah, maybe this is not a problem if we use more soaking and we use the methods before mentioned. But we witnessed this cracking, this instant cracking when we opened the press. So we were thinking about that maybe if we let the press to be closed and let the wood cool down a little bit and let the tension reduce, then we won't have this this instant problem when you just open it and there is no compressing force, and then it just like explodes everything. Every tensional problem is just appears out of the wood and causing every kind of problems. And also, if that's just so the tempering. I was just thinking if we let it cool down in a closed area, and then a little bit we heat it up, like in drying chambers, then it would decrease the tensions in the wooden structure. But that's only an opinion. I don't know whether this could work. Yeah, this thickness is really, I think at least it's the limit that we can work with. For example, terrace flooring. This is still pretty thick, so we could maybe use smaller pieces for this technology, for this method, because if we manage to do everything right, maybe just the size is too big for this whole procedure to work properly. Yeah, and our big breakthrough that we realized, Jenny realized, I think, that we're supposed to put both of the wooden pieces with the side up, so one side. But we managed to put one of them. Can I use the?
Sure. Go ahead. So,
Where? I already have it, but I don't know whether you can see it from there.
yeah.
So we have these two pieces, and one of them had the grains running like this, and the other was the opposite, so it was running like this. And what we saw, or at least what happened, is so this is the bottom and this is the top, and the successful specimen is the one that was like this. So this one is pretty good, I can say, and you can see that the other one is just destroyed. It's absolutely broken. You can use it for anything. So this really brings up the importance of from which part of the wood do we cut out, like this or like that,
There's a difference.
or the heart. Yeah, it's really important for this method. It's maybe even the most important thing because it's just the wood is harder. So this part is much harder to compress like this than this lower part. So that's the thing we need to look at in the future.
There's one problem that this is kind of imported from Russia, Siberia, this raw material, and actually we don't know how the resins cut. They could make a cutting there, so there might be differences.
It's kind of even difficult. As I saw in Sommel yesterday, days ago, it was each time when they had some boards, it was very nice even board. In the middle there was a kind of a central part, and it was evenly distributed rings. This is probably reason because you are using small diameters or smaller than it's usually done in Europe. Once you have a bigger one, you end up with different kind of planks or boards.
Yeah, usually here the Nordic sewing method is that we take sideboards are mainly 22 or 25 millimeter.
Yeah.
They have a certain purpose, and this kind of material is cut it from the middle.
Yeah.
And
so in Europe, this concern, I think it won't be able to, we won't be able to accomplish in a regular sawmill. It could be done, but it needs to be done some grading ahead of the time, or before this technology.
Good.
Yeah.
Comments?
I think that's it, and thank you very much for your.
Thank you. Teachers, do you have a further question?
One thing that I have been thinking about here is I'm wondering about the intermediate opening of the press, because maybe this is not a good analogy, but in panel production, for example, in plywood production, or even in wet fiberboard production, If you open the press in the middle of the pressing process, it means disaster all the time because there is a lot of, because most of the time, for example, for plywood pressing, you only need a couple of minutes maybe for the glue to start sufficiently setting. But the problem is with the steam buildup inside the panel that has to gradually, slowly get out of the panel, so you cannot open prematurely. So I'm wondering if maybe that is something that could be causing some of the problems that you are opening up kind of halfway through or even before halfway through the process, but there's still a lot of steam in there. I don't know if that has to be anything with this is a good analogy or not, but I'm wondering.
You guys are plywood experts, so.
Yeah, I totally understand what you mean. So when comparing the plywood process, so that we should get the steam out and be a little bit more gentle in the end. So not just decreasing the dirty bars and just open the. So we have to think about that. So that what is the best way? So that maybe we follow the plywood technology and go step by step and then open.
Any more questions? Suggestions?
I do have. When you start to talk about different way of getting water out from the wood, I just admire that you basically describe the main problem of drying of wood, and we usually call it, or dryer people who do with wood drying, they call it moisture content gradient, which is kind of fancy word, but it's nothing else but the speed of drying, which is kind of also related to the direction of drying. So the main purpose of drying is to dry such a slow way so it doesn't create very high gradient. High gradient means also high tension or stresses in wood, and high stresses means cracks inside or on the surface. So the way I just wanted to, I don't know, express my my gratitude that you basically describe the main problem of this drying and making those cracks. And of course, and you find also the same solution as dryer do. They wanted to decrease gradient, which means they wanted to allow water to go from different directions, which is also good, or just slower down the drying process. So gradient didn't occurs, or high gradient, because you will always have gradients of moisture content. Stresses will not occur, which is also a good way. And of course, because of no stresses, no cracks. So
this gradient is a number that describes a different specimen of wood.
It describes direction, which means longitudinal, tangential, and radial, and also describes basically differences, local differences of moisture content in different directions.
I see.
Yeah.
Yeah.
Or the fastest way of drying, or directional drying.
Yeah, maybe we should just find a wood
Yeah.
that works best.
Your suggestion was a really good one. Allow water to go perpendicular to the rain, so it doesn't go only in longitudinal direction. And you increase the speed, but you decrease the gradient because you will have a lower length to move water through the wood.
Yeah, thank you. It was Andrew's work also, so I don't want to take all the credit.
Of course, whole team.
Yeah.
Thank you. This may be good please. Okay, then here we have team number 3. Can you please introduce the team?
Yeah.
Sorry, I don't remember names because.
There's a list on my check.
Yeah, okay.
Oh, here.
Yeah, okay. Here's food, and there's food, and Peter, and Christina, and I'm sorry, I don't remember which is which, but
Thomas.
yeah, what, and Patrick. And we had spruce and the simplest method of hot pressing. We didn't have anything to any grooves or surface treatment, just plain pressing. Yeah, I think we can go through the process.
All right. So we also started with spruce board and put it in the hot press. The goal was to have a dry board with smooth, well, top surface, and also to make the surface dense, make it hard. And the modifying conditions are shown here, so it really wasn't that complex. And the results are here. So we had a board with smooth center part of the top surface, but the edges are still slightly rough. We are satisfied with the increased denseness of the surface, but there are small cracks on the bottom side and also some bigger cracks you can see here. And because of the fastening of the side bolts, the whole board is warped a little.
And do you have any samples with you?
Yeah. So yeah, here you can see the warping a little bit and some cracks on the bottom side. Yeah, we thought that the cooling process in the end of the process would be a good idea, but because of the inner tension seems to be high, and you were talking about the steam inside. So yeah, the cooling process to solve it. And here we say testing a thicker material using a thicker material. That means if we are using the same mold we did, which caused that the press is only in the end the press is only pressing the mold. So that's why we didn't get the smooth surface all the way. And Benedek, maybe you can clarify the last one, the top plate with the same dimensions, that's the piece.
It was my idea, maybe I can draw.
Yeah, sure. You can even take that away. Yeah. So.
So basically we had the problem. There was the wood in the form, and when it absorbs the heat, it shrinks, like we know, but the form was like there, and we moved it wrapped a little bit this, and the plate and the plate that was pressing only on this area, that so we were thinking to about to smaller the dimension of the plate, so it's right and it's right over the material and made it from more flexible material, so it covered the whole surface of the sample.
Very good idea, yes. We can do that. Actually, we have already that kind of plates, and during when you were pressing and I was following, I almost said that change those belts, but I didn't want to break you pressing, so I wanted to see what is going to out.
And I'd like to add that one idea was just like he said that you should never open the press during the whole process. The sound was really loud when the cracks happened, but when we opened the press, that should be no on the process.
So maybe you don't have to open the press after the pressing is end. So cooling step can be important, because after we open the press like other teams, so everybody can experience that there is a big crack after that open press. So maybe the drying method is the most important because of the inner tensions, but we don't have too big cracks in spruce material, so only two big cracks the end of the test piece. I show some data for you. So the moisture content before hot pressing is around 120%, but maybe we don't have a perfect counting, but after hot pressing, the average moisture content is about 26 degrees percent, sorry. And we before so first that we cut moisture sample, yes. It's about 100 milliliters long, and after we take it to the dryer for 22 hours, and after the moisture content, that piece is 37%. Maybe anybody's something.
Was you that you were also checking that the mechanically the moisture content?
Yeah.
What was the result?
Yes. So it's about the end pieces. It's almost 3.2. It's about 3 and 4% moisture content. The end of the pieces. In the middle, it's higher than 8.7%.
how you can explain so big variation between these two methods measuring the moisture? So you mentioned 26% and then with mechanical testing methods, so it was rather low.
Yeah, so we dried the cotton pieces. Maybe we take it to a dryer, and with this method we have the same data. So at the end of the test piece, there's a lower than moisture content. It's about 3 and 4 percent, and at the middle there is 9 and 8.
But testing it in the oven, so that's the real way how to measure the moisture content. So it was rather high.
Yeah.
And that's what I'm wondering. So what was the reason for that?
Maybe I don't know. So unfortunately, our way, maybe we have some bad counting, or I don't know what the problem.
Okay, thank you. We have to remember that this group had a shorter time to make a report, and because on Thursday they had maybe 2 hours time to prepare it. And I think you have worked in the evening after the saunas and everything, so kind of a different situation. But anyway.
So do you have a question? Do you have still something to show?
No, the slideshow is here.
Okay.
So if there's
Okay, now questions. So that everybody understands, so that this group idea was that to make as dense as possible and as smooth as possible this side. So let's forget now this bottom side. So this was the target, and I think that you managed very well. So, but
so there is no other treatment, just this pressing?
there is no
Only pressing,
Only pressing.
quite smooth.
Yeah, I have this. Yeah.
And you can
I'm just
see
impressed that this sample is really, compared to the others,
Yep.
well done. Like,
Yeah.
it was
Actually, that's
probably the best solution.
this is soil nut is made like Nordic way. So,
Yeah, exactly.
yeah, it's different than large. But always when they're hard here, you can see the kind of little bit covered.
Yeah, of course, this is natural. Yeah. You cannot avoid it.
Quite good.
so no more questions.
What was the percentage of thickness change?
about starting size is 30 millimeters, and after all pressing we have this about 28 millimeters, so 4 millimeters difference. And if you see this test piece, you can see less crackings than the other test pieces. So maybe spruce is better than large and pine for this method. Yes, but yes, so we need to test more and more. Yes.
I have a question. Is pressing and temperature schedule, every group has the same one? Was it
No.
So it was different. And is,
Almost the same, I think.
temperature was the same. It was same, but all the other steps they varied a little bit.
Okay. Between those steps, each group has some steps. Between those steps, the pressing plates were not allowed to open. They were just pressing continuously or in steps only down. Yeah.
We opened between those steps and tightened the sides a bit because they were not even touching anymore.
Okay. Okay.
And
this
of
was
course,
the large.
That's when the cracks happened. Yeah.
Yeah, this was the large group. Yeah.
Okay. I was.
This one.
This one. Yeah. Screws. Yeah.
Okay, so you allowed kind of water to go out, maybe?
No, well, it's actually
In
kind
time.
of flew out
Yep.
already, and then the tensions cracked when we opened the press.
I see.
So, it could be if we do it more slowly, it wouldn't happen like that. But
Yeah.
if we just open it right away, it's exploded.
And also, we have group number 1 opened once the hot press because they treated the surface. And
Yeah,
then they
it
put
was at the
And
end.
group
Yeah.
number 2 also opened it. Should be
You opened
tightened.
also,
Yeah,
okay.
tightened the screws.
Yeah, I just wanna question you, Peter, because I really like the idea that we use a smaller pressing plate that can go between the two side presses, because as we can see, the surface has a concave, and but it's really good. I think that that's a really good surface. It's smooth, it's contracted, it's you can work with that, but it's kind of finished. I mean, you can't just grain it, because then the hard part will disappear. So we need it to be even. Do you think that your idea will make this concave disappear?
I think that this concave is mostly done that we tied too much the screws and
So the wood fall down, yeah.
yes,
I
so
see.
if there is some calculations how much tight the screws,
Yes.
so it doesn't make this.
Yeah, or make it automatically. I mean,
Yeah,
all the sides, because
for example.
we can't open it. We can't open the press side. But
But then you put it in the oven after pressing.
This
Yeah.
no.
And when you finished and
Environment which degrades the surface in a speed way. We won't wait 3 years because it's not 3 years for that project. But we have some equipment which allows us to speed up the degradation of the surface and then check what was the color change before and after that. Within 1 or 2 weeks of that treatment, it's probably similar like you will have this wood outside for 1 or 2 years, so it can help us. Then we can check the roughness, how smooth is the surface. How technology helps us to make the surface smooth, because idea is within 1 step create a product and not to use any other sub or after post-processing step, for example sanding or some kind of cutting game and so on. So we wanted to check roughness, how it is after the treatment. We wanted to check if we will use this coating, a water glass coating. We would like to know how good is fixed to the surface. So there are some tests which we can test adhesion or how the coating sticks to the surface. We can measure it. Hardness is also one of the good property for surface, especially for decking, or maybe you can create from this material also some kind of steps or stairs, which hardness also relates to abradability, kind of hard word for me. But this term just relates if we will use it this flooring system for many years in rush areas or offices. We want to know if this surface is capable to not be, how to say, not be brushed down by using. So it's kind of easy test to do, and I think you will see more when we will done this test. I put 3 dots at the end because each time when we develop something and we try to figure out how can we test it or improve it, we have to have some tool so that tell us this product is better or worse. So sure, there are much more tests you can run in order to get a better and better product. Okay, that's all. If you have any question, hopefully I will answer. Welcome as well.
Thank you.
Thank you very much for your presentation. Very good presentation, and wow, we have already a program for the next workshop, which will be held in about middle of May in Zvolen. And well, it's kind of time for the closing words or something. What can I say? Whole week, the time went so fast. I have personally enjoyed really much, and I think it also. I'm very glad that you came here. We had the great workshop start for this 2-year project. And we have a lot of new friends. And we really look forward to see you very soon in Slovakia in May. It's only a few months, I think. Our students, they have, of course, hard season for studying, but in May I hope we can travel again. At least our lab students are the same, or who will travel with me and Ilkka to Zvolen. So first of all, I want to thank you, all the students who participated in this workshop. You really did a great job, I think, really great job. We had a nice week, nice workshop at laboratory, and also your presentation. And well, I haven't written yet your reports, but I'm sure that they're fine, and we can learn quite a lot of this and transfer some better practices for the next workshop. So I also want to thank our, the team leaders. We have had a great time together. I think even before a couple of weeks ago, we have practiced some things before the workshop, and you really did a great job with your teams. And you were kind of volunteers anyway. So Ilkka and I, we asked you that if you like to, or can you help us to organize this workshop? And you really did a good job. So thank you, Jenny, Martin, and Joni. And special thanks to Martin, of course. You have been with us for almost 6 months, and you're very soon leaving us and going back home to Slovakia. And we had, I think, a very great time with you. Well, Ilkka has spent more time with you, but I'm kind of new here. But at the beginning, when we met the first time, I know that you're really professional.
Thank you very much.
In food technology. Your expertise has helped a lot of us to build up this program also. Also, all the teachers, our guests, very special thanks to you also. It's really nice to have you here all, and we have a kind of good relationship, and I think we can further develop our the cooperation and everything. Like we had a meeting with the last yesterday about our future with how we proceed Hungary University, Zvolen. And I think we have a nice future with you also, Zvolen. We have already established the cooperation, and we have exchange students program already running and so on. Also our secondary schools from Slovakia, really glad that you came here also, and Sao Paulo also, that's our local partners. So we are pretty much related together in all the fields, but really nice to have you here. Well, what else I can say? Yeah, it's kind of, I had a quite busy, the past 6 months to build up this this project and workshop. Well, everybody knows what kind of things we had during that time. I want to go back that anymore, so I'm just so happy to be here now today. Ilkka, would you like to say something before we end up?
You already told almost everything, so from my side also, it was really nice to meet all of you here in Finland and in Lahti, and we are just waiting to meet you in Zvolen, so thank you for everybody here.
I think we all are winners, we can say.
Yeah, sure.
So I really look forward to meet you again very soon. So thank you. I think it's a time
And if I may also have a word for a minute, I think on behalf of all of your guests, I would very much like to thank you for all of the hard work that you and Ilkka and the group leaders and everyone put in into this workshop. It was a wonderful workshop. I think for all of us it was very well organized. Usually when a workshop is well organized, we don't really appreciate or see how much work goes into that, but I know that there was a lot of work on your part, and we would like to thank you for that. And obviously Rasto already mentioned about the workshop in Zvolen. I haven't said anything about the next workshop, which will be in Sopron. I will give you some more details about that when we are in Zvolen. It's still under development, but we have some very good ideas we have talked about, and I hope that I can only hope that we will be able to match the quality of this workshop, and we will be working hard on that. So thank you very much once again for everything that she did for us, for hospitality. Thank you.
Thank you.
And also don't forget the Jake.
Jake.
Yes. Jake was with us.
Yes, our media technique is going to make, of course, the video about our workshop. I'm going to have a discussion with the teachers and how do we make more than one video. I think we might make also the short video about all the, so we will we share all the the videos with you, and maybe we try to put it in some net link, also web link somewhere, and also you get the DVD product will be delivered to all the schools. About the feedback of the workshop during the February, we will make a questionnaire, and we send it to all the teachers, and then you get together your feedback from the students, also how you felt this first workshop, and the idea is that what results we get, feedback, we try to transfer the good practices to next workshop. That's the whole idea in this. Also, we are curious about to know how we managed to organize this week. So that's also. So, few words anymore when we are ready. So I think it's time to close our first workshop, and to thank you again. And I look forward to see you in Zvolen in May. Thank you. So if you need any help to schedules to buses or train. I can maybe print you some, you know, the or whatever. How can I help? So we can help.
So we can even take a look from here. We understood that somebody of you are going to Helsinki and somebody of you, one group is going to airport. You haven't decided yet.
Ja nie wiem, że mam praktycznie na izbach. Chyba nie chodził o pracować.
Ja mam tam jeszcze to, że...
Marek, ci prawo. No?
Thank you.